Good morning. Today we're going to talk about Math 101 in Section 2.4. That's Chapter 2, Section 4. The book's got kind of a long-winded title here. I'm just going to call it Solving Equations Part 1. And what the book does breaks up this topic into two sections, 2.4 and 2.5. And 2.4, it's going to be solving equations with the variable of interest only existing on one side. And as we'll see, we should be able to handle it on both sides of the equation, but we'll talk about that in section 2.5. All right, I'm going to go right to the book and start grinding out some examples. Hopefully this topic is at least somewhat familiar with us. This is example 1 on page 121. You'll recognize this type of problem. Solve the equation. Well, solve for the indicated variable means here solve for x, right? So 5x minus 7 equals 13. How am I going to handle something like this? Well, your goal here is to isolate the variable. The variable is only existing on one side of the equation, so if I can do algebra type things, meaning add, subtract, multiply, divide both sides of the equation through by factors of interest, I should be able to isolate my variable, get the variable on one side of the equation, and get a number or value on the other side, hence solving for a particular value of x or whatever value you're solving for. All right, here I would probably add 7 to both sides. The 7's, of course, cancel out on the left-hand side. That'll leave 5x equals 20, so my expression involving x is on one side of the equation. So now I'll just divide both sides by 5. The 5's cancel on the left-hand side. I'm left with x on the left equals, and of course 20 over 5 equals 4. All right, so this is how I would expose my final answer, x equals 4. Now the book goes through a big deal about checking all these equation solutions. I don't insist that you check your solutions on test day. It would probably burn up too much time to check each and every answer. Let's say if you're unsure about an answer, you might want to go back and check by substituting in your proposed value. Let's do it here. Again, I don't insist on this for each and every problem. I'm going to plug 4 into 5. Whoops, hang on a minute. 4 in for 5. That's 4 in for 5. 4 in for x in this equation. Let me get a different color here. All right, wherever I see an x, I plug in a 4 and see if my solution works out. So 5x turns into 5 times 4 minus 7 equals 13. Is that a true statement? If this reduces to a true statement, then my solution is indeed checked. 5 times 4 is 20. 20 minus 7 is indeed 13, so my answer checks out. Okay? Let's try example 2. Again, solving equations with variables on one side of the equation. This is example 2 on page 121. Solve. And of course, they're going to get a little harder as we go up the line here. Minus 2r minus 6 equals negative 3. All right, so we want to solve for r here. Clearly, well, my first step would probably be to isolate the expression involving the variable first. And I could do that easily by adding 6 to both sides. Whatever you do to one side, you got to do to the other to maintain equivalence. Of course, the 6 and minus 6 cancel out on the left. I'm left with minus 2r equals positive 3. And now you don't want to solve for negative 2r, you want to solve for r. So I'll divide both sides by negative 2. Of course, the negative 2's cancel on the left-hand side. I'm left with r all alone. That's what I'm looking for. And I end up with 3 over minus 2. Well, I can write this in any of three ways. 3 over negative 2, that's a fine answer. No mixed numbers, please. I could absorb that numerator, I could absorb that negative sign either in the numerator or denominator. And of course, I could equivalently move the negative sign outside the quotient process. All right, so any of these three answers would be acceptable on test day. Probably best to just pick one and circle it. Let's see. All right, and we'll go on to the next problem. All right, example 2. I'm not going to check this one, and it might just be too tedious to check at this point. Example 3. This is also, let's see, this is on page 122 in our text. You might want to look along. Of course, the author works these out step by step in great and formal detail. Of course, maybe I won't be so formal here. 16 equals 4x plus 6 minus 2x. Well, some of these terms involve x, are variables. Some of these terms are just values, pure numbers. All right, so what I'm going to do is, again, the goal here is to isolate the variable on one side of the equation. I would probably subtract 6 from both sides as a first step. Well, on the left-hand side, 16 minus 6 turns into 10. And on the right, I'm left with 4x minus 2x. Of course, 4x and 2x are like terms, and I can subtract them by subtracting the coefficients as indicated. I'll get 10 equals 4x minus 2x is, of course, 2x. And then divide both sides by positive 2. The 2's cancel out on the right, and 10 over 2 equals 5. So final answer is x equals 5. Notice in this solution, the variable is on the right-hand side, totally equivalent. If x equals 5, that's the same as 5 equals x. These are equivalent statements. All right, so you can adjust and bring your variable to either side of the equation that you like. I think most students in this case would prefer to put the variable on the right-hand side, okay? All right, example 3. Let's try example 4. Again, page 122. Again, it's worked out in the book step by step if you want to look along. Probably a good idea. 5x minus 2 times x plus 4 equals 3. All right, now we've got an x here trapped inside a symbol of grouping, an x plus 4, isolated in parentheses. So what I'm going to have to do is get rid of those parentheses, and I'll do that by multiplying through with my distributive law, right? Let me get another color here. I'm going to perform my distributive law, multiply both of these items by negative 2. That's the factor sitting out in front here. All right, so that'll be my first step. 5x minus 2 times x is negative 2x, and then minus 2 times positive 4 gives me a negative 8. Be sure to carry that negative factor through. All right, now I can combine some like terms. Well, of course, 5x minus 2x will combine as 3x. Minus 8 equals 3. Of course, I can add 8 to both sides. Again, my goal here is to isolate the x term. So I get 3x equals 11, and dividing both sides by 3, I'll get the final solution, x equals 11/3. Now, no mixed numbers, please. That's a fine answer. 11/3 is a real number. It lives on the real number line. Okay, so no mixed numbers, no decimals. Let me specify that. No mixed numbers, please. They've kind of lost their charm at this level and above in math courses. no mixed numbers, and no decimals, please. Okay. Example 4. Let's look at example 5. Oh, I'm out of room. Let me get another screen. Example 5. This is also on page 122. 3p minus parentheses 2p plus 5 equals 7. Somewhat similar to the last one. We've got a p variable here, but it's trapped inside parentheses, so we'll have to do some adjustment here to get that term out of the parentheses so we can combine it with the other p term. All right, what I'm going to do is distribute this negative sign through this parentheses sum. All right, and I can do that very easily. All right, minus 2p is negative 2p, and don't forget to carry through. Minus positive 5 is going to be a negative 5. So basically negate everything in that parentheses operation, and lets me drop then the parentheses. So now I can add or subtract as indicated. 3p minus 2p is 1p, or just p. And if you want to do more than one step at a time, that's fine. Here I would, all right, we're left with this statement, p minus 5 equals 7. At this point, I will add 5 to both sides, maintaining balance. The 5's cancel here, so p equals 7 plus 5 is 12. P equals 12. Final answer. All right, I want to do some solving some equations. We'll still have variables only on one side of the equation, but some of our coefficients are going to be fractions here. So let me write that down. Equations involving fractions. Again, with variables only on one side of the equation, as they all are in this section. I want to look at example 7. In your text on page 124, now we'll start out nice and easy. I've got 1/5 times x plus 1 equals 1. All right, you want to solve for x in this equation. Well, anytime you get an equation involving fractions, well, what's the first thing we don't do? The first thing we don't do is run to the calculator. Right? That's not going to help us here. If you run to the calculator on this problem, I can almost guarantee you're going to get it wrong. Right? The first thing I'm going to do is multiply by the least common denominator of all the fractions. Well, there's only one fraction here, and so there's only one denominator. So here the LCD, the least common denominator, is 5. If I multiply both sides by 5 and do it correctly, all these fractions are going to go away, and I'll have an easier problem, much like the ones we've already done earlier in this class. All right, so let me multiply both sides by the LCD, and the LCD here is 5, right? Both sides. All right, now multiplication is associative. Remember, in a string of products, I can multiply any two first. So I'm going to multiply 5 times 1/5 first. Well, of course, 5 times 1/5 is 1. And I've got 1 times x plus 1. Well, 1 times anything is itself. So the left-hand side reduces to x plus 1. No fraction. On the right-hand side, well, to maintain balance, we've got to multiply by 5 on the right-hand side also. And, of course, 5 times 1 is 5. So x plus 1 equals 5. I'll subtract 1 from both sides, and I'll get the result x equals 4. All right? So what do you do with equations involving fractions? Multiply by the LCD. Okay? Exclamation point. Get rid of the fractions so you don't have to deal with them. Okay. Let's try another one here. This is example 8 on page 124. Again, it's worked out in the textbook in great detail. D over 2 plus 3D equals 14. All right, here we've got, all right, two terms involving variables and one fraction. Well, again, let me write it down again. Equation with fractions. What do? Use the calculator? No. I'll even say no. All right, almost ensures you're going to get it wrong. All right, well, what will we do? Multiply both sides of the equation by the LCD of all fractions. Well, we've only got one fraction here, and it looks like the denominator is 2 here. So if I multiply both sides correctly by positive 2, I'll have an equation where I don't have to deal with the fractions. Well, the left-hand side is a sum, and when you multiply a sum, you've got to apply your distributive law. The right-hand side is just a number, so I'll just multiply that by 2. All right, let me illustrate our distributive law here. 2 times d over 2. Well, 2 times d over 2 is just d, is it not? The 2's will cross cancel, and I'm left with d. Plus 2 times 3d is 6d on the left-hand side. All right, so I can free up those variables from parentheses by applying my distributive law. On the right-hand side, 14 times 2 is 28. So let's see, d plus 6d. Well, those are like terms now, and I can add 7, get 7d, and 7d equals 28. Okay, we want to solve for d, not 7d, so I'm going to divide both sides by 7. The 7's cancel on the left-hand side. I've isolated d successfully, and 28 over 7, well, 7 divides evenly into 28. 7 goes into 28 4 times. Final answer, d equals 4. All right, one more. We'll call it a day. 9 on page 125. And please look along in the text. This one's kind of a nasty one, or nastier anyway. 1/5 x minus 3/8 x equals 1/10. All right, so again, our mode of attack here is when we've got equations involving fractions, you multiply through all terms, both sides, by the least common denominator, because then all these fractions will disappear, right? Well, what's the LCD of 5 and 8 and 10? Well, I think we can convince ourselves the smallest number that's a multiple of all three is going to be 40. All right, so I'm going to multiply both sides, all terms, by positive 40. All right, so here we go. On the left-hand side, you got a difference to worry about. So I've got to apply my distributive law. And this is example 9 on page 125. Take a little extra room here. So multiplying both sides now by 40. All right, I've got to apply my distributive law on the left-hand side. All right. Now 40 times 1/5 x, well, 5 will cross-cancel into 40 8 times, and 8 times 1x will give me 8x. Okay? Minus. Well, let's see. 40 times 3/8 x. 8 will cross-cancel into 45 times, and 5 times 3x is going to be a 15x. Let me put that in gold so we don't confuse anybody. $15x. In that second slot. And all the fractions are gone. Isn't that nice? On the right-hand side, of course, 10 cross-cancels into 40 4 times. So I've got the resulting equivalent equation, 8x minus 15x equals 4. All right, these are like terms, of course, so I can just add or subtract the coefficients as indicated. 8x minus 15x is minus 7x, of course, equals 4. I'll now divide both sides by negative 7. And I'll get x equals 4 over negative 7. Again, I can absorb that negative sign in numerator or denominator, or also say it's the negative of 4/7, even bring that negative sign outside the division process. I think our textbook and most students would probably agree that may be the preferred way to indicate the correct answer, but all three of these are acceptable and wonderful answers. All right, we're approaching the half-hour mark, so I'll call it a day. This concludes section 2.4, Solving Linear Equations, Part 1, Variables on one side of the equation.